Hi, welcome back to our AP Calc notes. Today we're going to look at 3.7 rates of change in the sciences. So all we're doing is just different kinds of derivatives. Nothing crazy, nothing really new. But we got the position of position of a particle is given by the equation S equals f of t, which is t cubed minus 6t squared plus 9t. And if we remember, we talked earlier in the year about how if f is position, then f prime is velocity, f double prime is acceleration, f triple prime, or the third derivative, is jerk. So you got position, velocity, acceleration, jerk. So if we want velocity, we want f prime, which is, we know, 3t squared minus 12t plus 9. Velocity after 2 seconds, just plug in a 2 into our velocity equation. So 3 times 2 squared minus 12 times 2 plus 9. This is 12 minus 24 plus 9, which is negative 3 meters per second. When is the particle at rest? So when is it at rest? That would mean when is the velocity at 0. So if you're at rest, that means you're not moving. If you're not moving, that means your velocity is at 0. So that's asking us, when is f prime equal to 0? Now we could graph this. That might be helpful. What do we got? 3t squared minus 12t plus 9. And so if we go to graph this, (3x squared minus 12x plus 9), we can find when our particle is at rest. It is at rest at 1 second and at 3 seconds. I can also just factor this, which would be 3t squared minus 3t minus 9t minus 9t plus 9 plus 9. If I factor this, I get a 3t squared, sorry, not 3t squared, 3t, t minus 3 minus okay, I need to slow down a little bit here. 3t t minus 1 minus 9 t minus 1, and then it's 3 t minus 3 t minus 1 equals 0. So my 2 times are 1 and 3 seconds. So at 1 second and 3 seconds, 1 second and 3 seconds, our particle is at rest. When is it moving forward? That's asking us when is f prime greater than 0? When is its velocity greater than 0? So if we go back to our graph, from 0 to 1, that velocity is positive. From 3 to infinity, the velocity is positive. This function right here is our derivative. It's our velocity function. So it's moving forward from 0 to 1. It's moving backward from 1 to 3, and it moves forward again from 3 to infinity. So when is it moving forward? It is moving forward from 0 to 1, and from 1 to infinity. So our motion of the particle, if I wanted to represent the motion of the particle, I could represent the position, I could represent the velocity. We're going to represent the velocity. So if I wanted to represent the motion of the particle, what I could do is I could do the position, which was 6x what's this? T cubed minus x cubed minus 6x squared plus 9x. 6x squared plus 9x. And then make sure you put that x to the third minus 6x squared plus 9x. Okay. So our function, our position function, shows the position of the molecule, and it's a cubic function, and it looks just like that. So it starts at 0, 0, which is appropriate. It goes up, it comes back down, or it goes forward, it goes backward, and then it goes forward again. So our position function